May 13, 1972. Thanh Hoa Province, North Vietnam. The Thanh Hoa Bridge stands defiantly across the Song Ma River, its steel and concrete spans carrying the only rail and highway route connecting Hanoi to southern North Vietnam. For 7 years, American aircraft have attacked this bridge. 873 sorties. Over 1,200 tons of conventional bombs dropped. 11 aircraft shot down. The bridge remains operational, its workers repairing damage each night, its defenders turning the approach corridors into killing zones of anti-aircraft fire and surface-to-air missiles. At 10:47 local time, an F-4 Phantom from the 8th Tactical Fighter Wing approaches from the northeast at 15,000 feet. The weapons systems officer in the rear seat tracks a pinpoint of reflected laser light dancing on the bridge's western span. The pilot releases a single 2,000-pound bomb. The Paveway 2 laser-guided munition falls away, its seeker head locking onto the laser designation. Guidance fins adjust continuously as the bomb falls, steering toward the precise point of laser reflection. 43 seconds after release, the bomb impacts within 3 meters of the aim point, striking the same structural member that 873 previous attacks had tried and failed to destroy. The western span collapses into the Song Ma River. The Dragon's Jaw, as American pilots called it, has finally been broken, not by overwhelming force, but by surgical precision. The revolution in aerial warfare has begun. For North Vietnam, the Thanh Hoa Bridge represented more than strategic infrastructure. It symbolized Vietnamese resistance to American technological superiority. The bridge had been completed in 1964, deliberately over-engineered to resist aerial attack. 540 feet long, the structure combined massive steel beams with reinforced concrete foundations anchored deep into the riverbanks. Engineers had designed it to survive anything American bombers could deliver. They were correct about conventional bombs. Between April 1965 and November 1968, American aircraft had attacked the bridge repeatedly. Each raid employed the standard tactics of the era. Multiple aircraft diving toward the target from different angles, releasing unguided bombs, hoping statistical probability would put enough ordnance on target to cause catastrophic damage. The mathematics were brutal. Bombing from 15,000 feet to avoid the heaviest anti-aircraft fire, conventional Mk-82 500-pound bombs and Mk-84 2,000-pound bombs achieved a circular error probable of 120 meters or more. Most bombs fell into the river or onto the surrounding countryside. Those that hit the bridge caused damage, certainly, but damage that Vietnamese workers could repair overnight using prefabricated steel sections stockpiled specifically for this purpose. The air defense network protecting the Thanh Hoa Bridge was the most concentrated in North Vietnam. Dozens of anti-aircraft artillery pieces ringed the structure, their crews trained to create interlocking fields of fire that forced American pilots into predictable approach patterns. SA-2 guideline surface-to-air missiles provided high-altitude coverage, while MiG-17 and MiG-21 interceptors could scramble from nearby airfields within minutes of raid detection. The price for attacking the Dragon's Jaw was measured in American lives. 11 aircraft shot down, pilots killed or captured, millions of dollars in lost equipment for damage that Vietnamese work crews repaired before sunrise. North Vietnamese propaganda made excellent use of the failed attacks. The Dragon's Jaw became a symbol of Vietnamese determination and American impotence. Radio Hanoi broadcast regular updates on bridge status, emphasizing how quickly damage was repaired and how futile American bombing campaigns had proven. The message was clear: American technological superiority meant nothing against Vietnamese engineering and willpower. Other strategic targets had proven similarly resistant to conventional bombing. The Paul Duma Bridge in Hanoi, a critical rail link connecting the capital to the port of Haiphong, had survived numerous attacks despite its obvious military importance. Petroleum storage facilities, protected by earthworks and dispersion, burned when hit, but rarely sustained permanent destruction. Supply depots and warehouses, hardened with concrete and buried partially underground, absorbed conventional bomb hits with minimal long-term impact. Railroad yards could be cratered, but repairs took only days. Cave complexes in the karst formations of northern Vietnam provided virtually impregnable storage for supplies, with entrances too small for unguided bombs to reliably hit. North Vietnamese defensive doctrine had evolved specifically to counter American conventional bombing. Harden critical targets with concrete and steel. Disperse assets across multiple locations. Maintain repair teams and stockpiles of replacement materials. Force American aircraft to fly through concentrated anti-aircraft fire, making each attack costly, regardless of results. The strategy worked because American bombs couldn't hit precisely enough to destroy hardened targets with single strikes. Overwhelming firepower was required, and overwhelming firepower meant multiple sorties, sustained campaigns, heavy aircraft losses, an enormous expenditure of ordnance that rarely justified the results. What North Vietnamese engineers and military planners didn't know was that American weapons designers had already solved the fundamental problem of aerial bombing accuracy. The solution didn't require more powerful bombs or more aircraft. It required teaching bombs to guide themselves to targets. The Paveway laser-guided bomb program began at Texas Instruments in 1965, a direct response to the frustrations of conventional bombing in Vietnam. The core problem was obvious. Unguided bombs followed ballistic trajectories determined solely by release parameters. Aircraft speed, altitude, angle, wind conditions, atmospheric density, all affected where bombs landed. Pilots released ordnance based on calculated aim points, but dozens of variables influenced actual impact location. Even the best bombardiers operating under ideal conditions achieved accuracy measured in tens of meters. Under combat conditions, with aircraft maneuvering to avoid anti-aircraft fire and releasing at high altitudes for safety, accuracy deteriorated to over 100 meters. Colonel Joseph Davis Jr., director of the Air Force's Guided Weapons Division, proposed a deceptively simple solution: add guidance capability to existing bombs, rather than designing entirely new weapons. Take a standard Mk-82 500-pound bomb, Mk-83 1,000-pound bomb, or Mk-84 2,000-pound bomb, and attach a guidance kit consisting of a laser seeker in the nose and movable fins at the tail. The total cost would be a few $1,000s per weapon, a fraction of what fully guided missiles cost, and the modification could be performed on existing ordnance stockpiles. Texas Instruments engineer Weldon Word led the technical development. The concept relied on laser designation. An aircraft or ground-forward air controller would illuminate the target with a pulsed laser beam. The beam would reflect off the target, creating a basket of laser energy. The bomb's seeker head would detect this reflected laser light and generate guidance commands to steer toward the brightest point of reflection. As the bomb fell, movable fins would adjust continuously, correcting the trajectory to keep the weapon aimed at the laser designation point. The first-generation Paveway wind system became operational in 1968. Early combat trials demonstrated revolutionary accuracy, 10-meter circular error probable under good conditions. Weapons systems officers reported an almost surreal experience, releasing a bomb, watching it guide, seeing it impact within meters of the exact point they had designated. For pilots who had spent years dropping dozens of bombs, hoping a few would hit close enough to matter, the precision was almost incomprehensible. Paveway 2, introduced in 1970, improved on the original design with a more sensitive seeker and better guidance algorithms. Circular error probable decreased to 3 meters. A weapons systems officer with steady hands and clear visibility could put a 2,000-pound bomb through a window from 15,000 feet. The implications for strategic bombing were revolutionary. Targets that required 100 sorties with conventional weapons could be destroyed with a single Paveway-equipped aircraft. The technology required laser designators that could reliably illuminate targets from aircraft or ground positions. The AN/AVQ-9 Pave Knife laser designator pod could be mounted on F-4 Phantoms, providing self-designation capability. The same aircraft that released the bomb could guide it to target. Later systems like the AN/AVQ-10 PaveTac offered improved performance and additional capabilities. Forward air controllers on the ground received man-portable laser designators. allowing them to guide bombs released by aircraft that never needed to see the actual target. The doctrinal shift was profound. Precision strike replaced carpet bombing. Single aircraft could accomplish missions that previously required squadron-level operations. Targeting moved from area attacks to point destruction. The pilot's role changed from delivering maximum ordnance to delivering precise ordnance. Training emphasized weapons systems management, laser designation techniques, coordination between designating and releasing aircraft, and target identification from sensor feeds rather than visual recognition. Initial resistance came from within the Air Force itself. Some senior officers viewed laser-guided bombs as expensive, unproven technology that couldn't perform under combat conditions. The cost per weapon was higher than conventional bombs, even if total mission costs were lower. Combat testing was limited, and reliability concerns persisted. What if the laser designator failed? What if weather obscured the target? What if enemy countermeasures jammed the seeker? Traditional bombing had limitations, certainly, but it was understood and predictable. Precision guidance represented a leap into unknown operational territory. The urgency of Vietnam operations overrode these concerns. By 1972, with the Paris Peace Accords under negotiation and American ground forces withdrawing, the Air Force faced pressure to demonstrate that air power alone could force North Vietnamese concessions. Operation Linebacker, launched in May 1972, would provide the testing ground for precision-guided munitions on an unprecedented scale. The early successes of laser-guided bombs in 1970 and 1971 had already demonstrated the technology's potential. Petroleum storage facilities that had survived dozens of conventional attacks were destroyed with single paveway strikes, the bombs penetrating earthwork protection and detonating inside storage tanks. Bridges that had been damaged repeatedly but never destroyed now collapsed under precision attacks that destroyed specific structural members. Supply depots protected by concrete were demolished when bombs struck the same point repeatedly, overwhelming the protective structures. Railroad locomotives, impossible to hit reliably with unguided bombs, were destroyed with surgical strikes that also demolished repair facilities and maintenance equipment. But the Thanh Hoa Bridge remained the ultimate test. 7 years of conventional attacks had failed. If Paveway could destroy the Dragon's jaw, it would validate precision-guided munitions as the future of strategic bombing. The mission launched on May 13, 1972, employed careful planning that would have been impossible with conventional weapons. Rather than saturating the target area with bombs and hoping for hits, mission planners identified specific structural vulnerabilities, the connections between the western span and its supporting pier. Destroy that connection, and the entire span would collapse under its own weight. F-4 Phantoms from the 8th Tactical Fighter Wing would conduct the attack, with one aircraft designating the target, while others released Paveway 2 guided bombs. The aircraft would approach at 15,000 feet, well above the most dangerous anti-aircraft fire, and release from outside the envelope of most surface-to-air missiles. The mission would last minutes instead of the sustained attacks required for conventional bombing. The first bomb impact collapsed the western span exactly as planned. A second mission on May 27th destroyed the eastern span, completing the bridge's destruction. 2 Paveway missions had accomplished what 873 conventional sorties could not. The cost differential was almost obscene. The 873 conventional sorties had expended over $50 million in ordnance, aircraft operations, support costs, and replacement of lost aircraft. The 2 Paveway missions cost approximately $30,000 in guided munitions. The bridge that North Vietnamese propaganda had declared indestructible lay broken in the Song Ma River, destroyed not by overwhelming force, but by precision that made overwhelming force unnecessary. The Paul Doumer Bridge in Hanoi, another symbol of failed American bombing campaigns, fell to Paveway attacks in October 1972. 4 sorties destroyed 2 spans, severing the critical rail link between Hanoi and Haiphong. Previous conventional bombing campaigns against this bridge had involved over 100 sorties with minimal lasting damage. The contrast was definitive. Precision guidance changed the fundamental mathematics of strategic bombing. Barracks complexes, supply areas, and command centers Targets previously considered marginal for aerial attack because of the ordnance required to ensure destruction became high-priority targets for Paveway-equipped aircraft. Buildings could be destroyed with single bombs. Specific structures within larger complexes could be targeted while leaving surrounding facilities intact. Mission planning focused on identifying critical nodes rather than saturating entire areas with bombs. Railroad yards, which had absorbed endless conventional bombing with minimal long-term disruption, became vulnerable to precision attack. Instead of cratering rails that could be repaired overnight, Paveway bombs destroyed locomotives, rolling stock, repair facilities, and switching equipment. The difference was strategic. Conventional bombing damaged infrastructure that could be quickly restored, while precision strikes destroyed equipment that required weeks or months to replace. The petroleum pipeline network that supplied North Vietnamese forces had proven almost invulnerable to conventional bombing. Buried underground or protected by earthworks, the pipelines themselves were difficult to damage permanently. But pipelines required valve stations, pump houses, and above-ground distribution facilities. Paveway bombs could destroy these specific components, shutting down entire pipeline sections without needing to destroy the pipes themselves. The doctrine of attacking system vulnerabilities, rather than attempting to destroy the entire system, represented a fundamental shift in strategic thinking. Cave complexes carved into karst limestone formations throughout northern Vietnam had provided virtually perfect protection for supply stockpiles. The caves themselves were too deep for conventional bombs to penetrate, and their entrances were too small for unguided bombs to reliably hit. A bomb that missed the entrance by even a few meters was wasted. Paveway guidance made cave entrances viable targets. Forward air controllers could designate cave mouths with lasers, and Paveway-equipped aircraft could guide bombs directly into openings that would have been impossible to hit with conventional weapons. Supplies that North Vietnamese forces had considered safe from aerial attack were suddenly vulnerable. Operation Linebacker II, conducted in December 1972, demonstrated precision-guided munitions at maximum scale. B-52 Stratofortress bombers, traditionally employed for carpet bombing, with hundreds of unguided bombs, now carried 2,000-pound Paveway laser-guided bombs. The targets were specific buildings in Hanoi, command centers, communications facilities, supply warehouses. The bombing destroyed designated structures while leaving surrounding buildings intact, a level of precision impossible with conventional bombing. The political and psychological impact was profound. North Vietnam's leadership could no longer assume safety, even in the capital's most protected areas. The statistical impact of Paveway munitions during Operation Linebacker was remarkable. Laser-guided bombs comprised approximately 1% of all sorties flown during the campaign, but were responsible for destroying an estimated 40% of strategic targets. The efficiency ratio, destruction achieved versus sorties flown, exceeded conventional bombing by orders of magnitude. Individual aircraft achieved results that would have required squadron-level operations with conventional weapons. The cost-effectiveness extended beyond ordnance expenditure. The Thanh Hoa Bridge example was illustrative. 873 conventional sorties had cost over $50 million in bombs, fuel, support operations, and aircraft losses without destroying the bridge. 2 Paveway sorties costing $30,000 in munitions accomplished complete destruction. The return on investment was nearly 2,000 to 1. For a military engaged in an expensive and politically unpopular war, the economics of precision-guided munitions were compelling. Pilot safety improved dramatically with Paveway employment. Conventional bombing required repeated low-level passes through intense anti-aircraft fire to achieve target saturation. Precision-guided munitions allowed release at 15,000 feet or higher, outside the envelope of most anti-aircraft artillery. Surface-to-air missiles remained a threat, but the reduced exposure time and elimination of repeated passes lowered overall risk significantly. Aircraft losses per target destroyed decreased substantially for Paveway-equipped missions compared to conventional bombing campaigns. North Vietnamese forces struggled to comprehend the technology they faced. Traditional air defense doctrine assumed that aircraft had to approach close to targets and remain in the area long enough to deliver multiple weapons. Radar operators reported aircraft releasing single weapons from high altitude and immediately departing. But the results were devastating. A single bomb would destroy a bridge span, collapse a building, or demolish a hardened bunker. It seemed impossible by the standards of conventional bombing. Vietnamese air defense units attempted various countermeasures. Smoke generators were positioned around critical targets with the intent of obscuring laser designation. The theory was sound. If the laser designator couldn't see the target, guidance would fail. In practice, wind dispersed smoke too quickly to provide consistent protection, and laser designators could simply wait for clear air before designation. Some attempts were made at laser detection, using sensors to identify designation beams and alert defenders. But laser designators could switch frequencies and modulation patterns, and detection alone didn't provide a way to defeat the incoming weapons. The fundamental problem for North Vietnamese defenses was that laser-guided bombs defeated the entire doctrine of hardening and rapid repair. Conventional bombing scattered explosives across target areas. Some hit earth, some hit water, some hit structures. Hardening meant building strong enough to survive near misses and designing for rapid repair of partial damage. Rapid repair worked because conventional attacks damaged targets, but rarely destroyed critical structural elements completely. A damaged bridge could be patched. A cratered runway could be filled. A partially collapsed bunker could be reinforced. Precision guidance eliminated the distinction between near misses and hits. Every paveway bomb that guided successfully hit within meters of the designation point. If the designation point was a critical structural member of a bridge, that structural member would be destroyed. If the designation point was the roof of a bunker designed to withstand near misses, the bomb would punch through the roof directly. If the designation point was a locomotive inside a locomotive shed, the locomotive would be destroyed and the shed would collapse on top of it. Hardening protected against scattered conventional bombing, but provided no defense against precision strikes that hit the same point repeatedly. A concrete structure could survive one direct hit, perhaps two, but paveway-equipped aircraft could guide multiple bombs onto the same structural element until it failed. The repair doctrine that worked against conventional damage, patching and reinforcing between raids, couldn't keep pace with precision destruction. A bridge span that collapsed into a river couldn't be patched overnight. A power plant, with its turbines destroyed, couldn't generate electricity regardless of how quickly the building was repaired. A petroleum storage tank penetrated by a precision strike burned until empty, and no amount of rapid repair could restore the lost fuel. The economic implications were equally significant. North Vietnamese strategy had relied on dispersing critical assets across multiple locations, forcing American bombers to attack many sites to achieve meaningful disruption. Precision-guided munitions made dispersion less effective because each dispersed site could be destroyed with minimal sorties. A dispersed petroleum storage network with 20 sites had seemed resistant to conventional bombing. Attacking all 20 sites required hundreds of sorties. With paveway guidance, 20 sites could be destroyed with 20 sorties, perhaps fewer if multiple bombs were guided to each target. The force multiplication of precision guidance meant that dispersion no longer provided the protection it had under conventional bombing. Soviet military observers studying American precision-guided munitions during the Vietnam War recognized the revolutionary implications. The Soviet Union began development of laser-guided artillery shells under the Krasnopol program and laser-guided bombs under the KAB series designation. However, Soviet technology lagged significantly behind American capabilities. The first Krasnopol-guided artillery shells didn't enter service until the 1980s, and early KAB laser-guided bombs suffered reliability and accuracy problems. The technology gap that had opened in the 1970s would persist for decades, with Soviet and later Russian precision-guided munitions remaining inferior in performance and availability compared to American weapons. Post-war assessments by North Vietnamese military officials acknowledged the decisive impact of precision-guided munitions on the bombing campaigns of 1972. One senior air defense officer stated in interviews conducted in the 1980s that precision bombs had fundamentally changed the nature of air warfare, making it impossible to defend critical infrastructure through hardening and repair alone. The admission was significant. North Vietnamese forces had successfully resisted American conventional bombing for years, but had no effective countermeasure to precision-guided weapons. The legacy of the Paveway laser-guided bomb program extended far beyond Vietnam. By the time of the Gulf War in 1991, precision-guided munitions had become standard in American air operations. Over 8,000 laser-guided bombs were dropped during Desert Storm, destroying Iraqi command centers, communications facilities, hardened aircraft shelters, and armored vehicles with efficiency that shocked international observers. Iraqi forces, equipped with Soviet weapons and trained in Soviet doctrine, discovered that their defensive preparations, hardening, dispersion, camouflage, provided minimal protection against precision attack. The Kosovo conflict in 1999, Afghanistan operations beginning in 2001, and the Iraq War starting in 2003 all saw extensive use of precision-guided munitions. The Paveway family continued to evolve. Paveway 3 entered service in 1987 with improved guidance and range. Paveway 4 in the 2000s added GPS-aided navigation for all-weather capability. Modern Paveway munitions achieve circular error probable of 1 meter or less, allowing destruction of point targets with minimal collateral damage. The development of GPS-guided joint direct attack munitions in the 1990s supplemented laser-guided bombs with all-weather capability, independent of laser designation. GPS guidance could penetrate cloud cover and operate in conditions where laser designation was impossible. However, laser-guided bombs retained advantages for attacking moving targets and final phase precision that GPS alone couldn't match. Current doctrine employs both technologies complementarily, with mission requirements determining optimal weapon selection. Export of Paveway technology to Allied nations meant that precision-guided munitions became standard throughout NATO and Allied air forces. Over 35 countries currently operate laser-guided bombs based on the Paveway design, either manufactured domestically under license or purchased directly from American manufacturers. The proliferation of precision-guided munitions represented a fundamental shift in global air power, with major implications for conventional deterrence and military planning. The cost of Paveway munitions increased over time as seeker technology improved and additional capabilities were added. Early Paveway 2 bombs cost approximately $3,800 in 1970s dollars. Modern Paveway 4 munitions cost over $20,000 per weapon in current dollars. However, the cost-effectiveness ratio remained favorable compared to conventional bombing. A modern precision-guided munition costing $20,000 that destroys a target with a single strike is dramatically more economical than multiple sorties with conventional weapons costing millions in total mission expenses. The doctrinal revolution enabled by precision-guided munitions extended beyond tactical targeting to strategic concepts. Effects-based operations, the doctrine of achieving specific strategic effects through targeted destruction of critical nodes, became possible only with weapons accurate enough to reliably destroy designated targets. Traditional attrition warfare assumed that overwhelming firepower would eventually degrade enemy capabilities through cumulative damage. Precision warfare assumed that destroying specific critical components would collapse enemy capabilities more efficiently than broad attacks. The distinction was fundamental. Precision guidance changed warfare from a game of quantity to a game of targeting intelligence and weapon accuracy. The Thanh Hoa Bridge, rebuilt after the war, still stands today carrying rail and highway traffic across the Song Ma River. The structure serves as a reminder that the revolution was in the bridge's destruction. Bridges can always be rebuilt. The revolution was in the technology that made precision destruction inevitable rather than probabilistic. North Vietnamese engineers, who had designed the bridge to resist 1960s-era conventional bombing, faced 1970s-era precision that rendered their defensive calculations obsolete. Training programs throughout the United States Air Force adapted to emphasize precision employment. Weapons schools developed curricula focused on laser designation techniques, terminal guidance monitoring, coordinate systems for precision targeting, and battle damage assessment methods specific to precision-guided munitions. The skills required to employ precision weapons effectively differed fundamentally from conventional bombing. Understanding guidance mechanics, managing sensor feeds, coordinating designation and weapon release, and developing target folders with sufficient precision for meter-level accuracy. The reduction in civilian casualties achieved through precision-guided munitions had strategic significance beyond immediate humanitarian concerns. Conventional bombing inevitably produced extensive collateral damage. Most bombs missed their targets, and those that landed nearby destroyed whatever happened to be present. Precision guidance allowed destruction of military targets while minimizing damage to surrounding civilian structures. The political and psychological implications were substantial, particularly in conflicts where minimizing civilian casualties was strategically important for maintaining domestic and international support. Soviet and Russian military forces never achieved parity in precision-guided munitions. The KAB series laser-guided bombs developed in the 1980s and 1990s saw limited deployment and suffered reliability problems compared to Western equivalents. Russian air operations in Syria, beginning in 2015, demonstrated continued reliance on conventional, unguided ordnance for most strikes, with precision-guided munitions used selectively. The technology gap that opened in the 1970s persisted into the 21st century, with Russian forces lacking both the quantity and quality of precision weapons available to American and NATO air forces. Chinese military development produced the LT series laser-guided bombs in the 2000s, based on Western precision-guided munition concepts. Chinese weapons achieved reasonable accuracy and reliability, but the development timeline illustrated the difficulty of catching up. American forces had operated precision-guided munitions for 3 decades before Chinese equivalents entered service, providing enormous accumulated operational experience and continuous technological refinement. The modern battlefield reflects the dominance of precision-guided munitions. Unguided bombs remain in inventory and see use in low-threat environments where precision is unrequired, or against area targets where accuracy is less critical. However, any operation against opponents with significant air defense capabilities or requiring destruction of hardened or point targets employs precision-guided weapons as standard. The assumption that bombs will hit what they're aimed at, rather than landing somewhere in the general vicinity of the target, represents a fundamental transformation in how air power is conceived and employed. The distance between the 873 conventional sorties that failed to destroy the Thanh Hoa Bridge and the 2 Paveway missions that succeeded measures more than just sortie counts or ordnance tonnage. It measures the gap between guidance technology that made hitting a target certain rather than probabilistic. North Vietnam's Dragon's Jaw Bridge was designed to withstand 1960s carpet bombing. Hundreds of sorties, thousands of bombs scattered across the target area, overwhelming force applied broadly with the expectation that statistical probability would eventually cause sufficient cumulative damage for collapse. Paveway laser-guided bombs brought 1980s precision to 1972 combat operations. The revolution wasn't in explosive power or aircraft performance. The revolution was in guidance technology that transformed an uncontrollable ballistic trajectory into a controlled flight to a designated point. The difference between a bomb that falls where physics dictates and a bomb that flies where guidance commands measures the distance between warfare as an exercise in overwhelming force and warfare as an exercise in surgical precision. North Vietnamese defenders had designed their strategy around American reliance on conventional bombing. Harden targets, disperse assets, repair rapidly, force attackers to sustain campaigns that cost more in aircraft and ordnance than the results justified. The strategy worked for 7 years against the Thanh Hoa Bridge. It worked until precision guidance made hardening, dispersion, and rapid repair irrelevant against weapons that hit exactly where aimed every time. The workers who repaired the Dragon's Jaw after each conventional attack, the anti-aircraft crews who shot down 11 American aircraft, the engineers who designed reinforced structures to resist bombing, all operated under assumptions inherited from World War II and Korea. Assumptions that bombs scattered, that overwhelming numbers were required to ensure hits, that proper engineering could create structures resistant to aerial attack. Paveway guidance invalidated those assumptions in minutes. The bridge that had defied 873 conventional attacks collapsed under 2 precision strikes, because guidance technology created a new category of threat that traditional defensive measures couldn't counter. North Vietnam planned its air defense strategy for the War of 1965, conventional bombing with unguided weapons delivered by aircraft that had to approach targets closely enough for accurate release. America fought the War of 1985, precision-guided munitions released from standoff distances by aircraft that never needed to see their targets directly. The gap wasn't one bomb versus 873 sorties. It was guidance technology that made the difference between hitting near a target and hitting the target. Every time,